Alright, so in this one, we're going to try to make a suborbital flight. So we're going to build the same rocket from the tutorial, and then we're going to put it into my sim that I built in Python. So I got my command module, I need some fuel tanks, and I think it's just these FLT100 fuel tanks.
No, but we need to do like a flat.
Oh, that's right. Yeah, Elena's right. I need to be able to decouple. So I need a coupling joint because I need to at some point decouple the like when I'm in suborbital flight. I need to decouple the first stage. And then you think it's a different one?
No.
I think we're good. So now we can add some fuel tanks and add the FLT100. And in the tutorial, you hit shift, or right shift. There we go. You hit the right shift key, and they want you to do 5 of these. 1, 2, 3, 4, and 5. Okay, and then we need an engine, and then they make you use the swivel, LT45 swivel. So we'll throw that in here at the bottom. Oops. Okay. And then we also need a parachute, so we're going to throw the Mark 16 on there. And then in this one, you actually want it to deploy well within the atmosphere because you need to wait for the spacecraft to slow down. One thing that you need to do, though, is if you look at the center of mass and the center of pressure is super high above the rocket. And so in order to bring that center of pressure down, you need to increase the symmetry and add some fins.
This is my stool.
Elena, you're in the wrong stool. So there you go. So
You're the wrong stool.
Lily, just sit in my lap, Bubby.
No, I don't want to.
You don't want to? Okay. Yeah, Lana, you come in here. All right, perfect. Okay, so now our blue sphere, which is our aerodynamic term, is below there. So this is a stable rocket. I think we have everything we need. We need to stage it properly. So I want the rocket to deploy, and then I guess I needed to add one, and then I want the coupling joint. There we go. So it'll be rocket, coupling, and then parachute. And I want to say I have everything I need. So we're going to call this suborbital, okay? And then we're going to save it. And then now what I'm going to do is I want to grab all of these parameters. So I've got a thrust of 167.97.
I don't want you to do this.
I know. I'm going to do it real fast. 167.97. And then an ISP of 250 seconds. Okay, and then we need the initial mass of 5.3 tons, so 5.3 tons is the initial mass, and the end mass is 2.8. 2.8. Now my drag term is going to be totally off. I'm going to make it 0.4 just because I'm guessing. And let's see, according to this, I am going to go outside the atmosphere, right? So the atmosphere is 70,000. So let's simulate this for 300 seconds. And according to my sim, there we go. So it looks like there's my suborbital flight with an apogee of 110 kilometers. So let's see what happens. So let's hit save, launch. Now, in the tutorial, it says that if you launch this rocket at full throttle, you will punch through the atmosphere so fast that you will actually burn up in the ascent phase. So if you look at the throttle term down here, left shift is throttle. So what we actually want to do is do 2/3 throttle. We want to hit T as in tango, and turn on our stability augmentation system. And Jebediah is ready to go, so we're going to hit spacebar and take off. And what we want to do is when we hit, and according to the tutorial, we want to have a nice arc. So at 50 meters per second, we're going to start to angle, and we want to make like a nice ascent arc. This is what they do in real life. our stability augmentation system is essentially going to keep us there. Once we hit 250 meters per second, we're going to angle more. We're shooting for 70 degrees, so we're not quite there yet. And we're still well within the atmosphere, so again, we don't want to just like completely blow up our spacecraft here. So okay, so now I'm going to hit F12 again, so you can kind of see the drag that's happening here. And again, see, we're going to have some lateral drag turns. So I'm going to angle it more. Let's see, angle it more. Still going. Oh shoot, I forgot about the science experiment. Yeah, so we're not going to have, we might have not enough drag on this. But I think we're okay. So I'm trying to remember the density spectrum. It looks like my aerodynamics are going down and I'm almost running out of fuel. So I'm going to go ahead and punch it and hit full throttle. And then I'm also going to... okay, yeah, so now I'm getting hot. Oh man, may have punched it too much. I'm going to bring down the throttle. Oof. I'm cooking. I think we made it. Oh, I'm cooking. Okay, I made it. All right, so we're out of the. We're definitely outside. We're getting outside the atmosphere. You can see the atmosphere term is coming down, and at that point, I think we can hit M, because I'm out of fuel. So now we're just coasting, and so here's my orbit, and there's my apogee at 104. It's still coming down, and the reason why it's coming down is because I'm still in the atmosphere, and so I haven't fully reached coast. Okay, we want to keep this. We want as much mass as possible right now, because we're still our drag is still slowing us down, and so believe it or not, the more mass you have, you'll punch the atmosphere better. You require more thrust, but I'm coasting. So we want to keep until I'm at 70 kilometers. I don't want to deploy the rest of my spacecraft, and it looks like my apogee is pretty much constant. It looks like it's still changing a little bit, but I got a pretty nice arc here. I feel like 104. My simulation predicted 110, but that was with no arc. So I think I did pretty good in the sim, guessing the aerodynamic velocity. What's going on, kids?
I need to get out.
Luis, you sit in my lap.
No!
Okay. Let's see. All right, so I'm well outside the atmosphere, so I'm going to turn off stability augmentation, and I'm going to... What's interesting about...
Mommy, what is that?
That's 24 inches. What's interesting about in space is that there's no drag, right? So if I spin the spacecraft, it's just going to spin forever. And then if I hit, A for the other direction, you can see the swiveling happening, which is kind of cool. So I'm going to hit stability augmentation to lock me into 90 degrees, and I'm going to deploy the stage, okay? And so now things kind of get pretty, so that's kind of cool because it just sort of flies away. And there I am. I still haven't hit apogee yet. I'm still getting there. And there's my other spacecraft flying away. So now I'm going to turn off stability augmentation, because what I want to do is, if you look at the ascent phase of the suborbital flight, I came in at 70 degrees, so I want to fall back at 70 degrees. So I'm going to hit M again as in Mary, and I'm going to turn off stability augmentation. I'm going to angle my rocket. I can't really see. There we go. To 70 degrees. So hit T, boom. All right, there we go. So I am locked in at, it says 30, but it's 70 from if you go this way, right? Jebediah is still doing good. I haven't armed my parachute yet. I do want to make sure that my velocity comes down significantly. At this point, we can just chill. We're our altitude. We've already hit apogee. Our apogee's coming down. Our altitude is coming down.
Don't touch it. Don't touch it.
The kids are measuring my desk here. It's cute. This is what it's like working from home. So I don't have a heat shield, but I don't think it's going to be a big deal. So what's interesting here too is if you look at surface velocity versus orbital velocity. So surface velocity is your velocity of your rocket with respect to the Earth, right? Or the Kerbal. Because the planet itself is rotating. And so when you take off from the planet, you get that little bit of like orbital assist, which is really nice. But if you click surface, right, it's lower because it's just your velocity with respect to there. I'm gonna pause the video for a second. Okay, tape measure got taken away. I paused the video. So let's. I kind of want to do a time warp. Well, no, I mean I'm getting close to getting into the atmosphere. So I'm already at 66 kilometers. Stability augmentation is keeping me in the right configuration. I am in a unsafe position to deploy the parachute, and my altitude is coming down. My velocity is coming down. I mean, I can just go ahead and just plot surface velocity here. And as soon as I get into this like light blue region, we should start to see some fire, and hopefully, oh, that's kind of cool. It's still modeling the other part of the spacecraft. And actually, it's yeah, okay. So all right, there we go. So it doesn't look like I'm angled properly, so I'm going to, there we go, rotate it into there. And I'm hoping, that's a lot of drag, I'm hoping that I'm going to bring my velocity down to below 300 meters per second. And then that way I can deploy my chute. Okay, so I still got a ton of drag. And my velocity is coming down. I'm still in an unsafe configuration to deploy. Let's see, still coming down. Okay, so now I'm in a safe position to deploy, but as long as my velocity is declining, I'm not going to deploy yet. If it starts to climb, that's where we're running into trouble. So it looks like it's slowing down. So I'm going to go ahead and activate the chute. And then it's still coming down, so we think we're okay. The way I have it set up right now at 0.75 is it should deploy the drogue chute at 2 kilometers. So again, as long as this number is coming down, we're okay. We're not increasing. It looks like I have enough drag where I haven't hit terminal velocity yet, I guess. Well, then again, I'm also plunging into the atmosphere, so density is increasing. Okay, so here's 2,000. And there you go. There's the drogue chute. And then 1,000, it should fully deploy. And we did it. We did our suborbital flight successfully in sandbox mode. And that was, I don't know, this game is a lot of fun. I'm really enjoying it. So I guess the next step is to get into orbit. So if you saw in the suborbital period or suborbital trajectory, our apogee was 110 kilometers. That's well outside the atmosphere. So all we need to do is make a 2-stage rocket so that at apogee we burn again and circularize the orbit. And that's essentially what we're going to do. You want to swim?
Yeah, fill in the swim.
Yeah, we can swim a little bit. We just got 100 meters left before we collide with the water here. Jebediah is going to get out and do some swimming. So I wonder if maybe we should just do a little bit of time warp here, just so we hit the ground faster. Well, not hit the ground faster, but simulate faster. And right when we get to like 10 meters, there we go. I'll bring it down to 1. Okay, we've hit the ground. Jebediah's like, what's going on? And then there we go. We are outside, And we're going to hit F.
Climb? Can we climb?
We're going to hit space to swim around.
No,
And then Elena, what she likes to do is she likes to climb the spacecraft. Okay. And then get on top. And then jump off. And make a splash. So there you go. All right. There you go. So we did our successful flight. Let's go ahead and recover the vessel. And that's it. So I hope you enjoyed this video. And stay tuned for getting into orbit. What do you think?